All right, for this last video, I want to get you started on the worksheet that you're going to be filling out for class today. Today we're going to go, in class, we're going to go over the worksheet, see if we hit any snags. And I'm actually going to help you through the first snag. Normally I let you struggle through it. I'll give you a few moments of struggling, but I'll correct you pretty quickly here. So here's the question for us. And the question is this: how is the hatching of python eggs influenced by the temperature of a snake's nest? Thought I'd get a little reptilian on you today. So for this experiment, the data from which we're going to analyze, researchers assigned newly laid eggs to one of three temperatures: hot, cold, or neutral. Hot duplicates the extra warmth provided by a mother python. Cold duplicates the absence of the mother. And neutral, you can imagine as being something in between them. So here are the data on the number of eggs and the number that hatched. So what you're going to do for this one is first, you're going to make a two-way table of temperature by outcome, hatched or not. Two, you're going to calculate the percent of eggs in each group that hatched. The researchers anticipated that eggs would not hatch in cold water versus warm. Do the data support that anticipation? And three, are there significant differences among the proportions of eggs that hatched in the three different groups? Okay, so the very first thing that you're going to need to do is to set up a table. What I've done here is I've actually given you the outlines of a table. In later worksheets and in an exam, what I'm going to do is just show you these three questions, something like this, and you're going to have to make your own table. But for right now, what I'm doing is I'm giving you a little bit of a table. And the table is this. One, we're going to take a look at these three different groups: hot, neutral, and cold. And we're going to assign those as three groups: neutral, hot, and cold. The second is we want to know if our eggs were hatched or unhatched. Okay, so the first thing I'm going to ask you is we're going to try to put our observed values into the table that we see. Okay, so let's take a look at, for instance, this cold hatched box right here and ask the question, what number is going to go in here? Well, to do that, we simply look up on our table here and we start with the cold, we go to the hatched, the cold hatched, and we observe that 16 of these eggs actually hatched here. Second, we want to know how many of the neutral eggs hatched. So again, we start with our neutral, we go over to the hatched, we find that 38 of our neutral eggs hatched. Oops. So our observation there is 38. Next, our hot hatched. We do the same thing, go over, and we find that 75 of our hot eggs that hatched. Okay, so now the next question is, now I'm going to fill in these other columns. So let's go to the cold unhatched. My question for you is, what number do we put in there for the observed? Pause the video, fill in a number, and then unpause the video. Okay, what many people will do is to fill in the number 27 here, because they've looked across and they've seen, well, this is another one of those cold eggs. Oops. This is another one of those cold eggs. There's 27. But take a look at what 27 actually is. 27 is the total number of cold eggs, not the number of unhatched eggs. Okay, so let's actually go back down here and delete 27 from right here. 27 actually goes down here. It is the total number of cold eggs. 27 is the total number of cold eggs. Okay, so if there's 27 total cold eggs and 16 of them were hatched, how many were unhatched? If you said 11 eggs, you're right. 16 hatched plus 11 unhatched leads us to the 27 total cold eggs. So now let's go down up here and we ask how many total neutral eggs, and what we see is 56. So under this neutral column, we'll put 56 total neutral eggs, and under the hot total eggs, we see 104. So we'll do 104. So take a minute and try to fill in the two remaining observations as well as the remaining total scores on the right. And in just a minute, I'll walk you through to check your work on those, and then I'll take you through one of these and we'll continue on. Okay, so if we take a look down here and we're looking now at the total number of unhatched neutral eggs, what we find is that 56 total neutral eggs minus the 38 hatched neutral eggs gives us a remainder of 18 unhatched neutral eggs. For the hot category, 104 total hot eggs minus 75 hatched hot eggs gives us a remainder of 29 unhatched hot eggs. And now we're going to add up and figure out what these row totals are. So over here, what is the total number of hatched eggs? Well, all we're going to do here is add 16 hatched cold plus 38 hatched neutral eggs plus 75 hatched hot eggs is going to give us 129 eggs. And one of the things I've already given you is the total over here, 187. So there's two different ways you can figure out how many unhatched eggs are left. One of them is to do the same thing where we add up 11 plus 18 plus 29. Or the other way to do it is to simply take 187 minus 129. But in either case, what we're going to get is, every once in a while, you're going to love this. Every once in a while, I got to write it somewhere else. 58. Oh my goodness. Let's try it again. 58. And now we'll move that up here. So we have 58 total. Okay. Now what I want you to do is I'll take you through one more. In fact, I'll take you through one whole column of expectations, and then I'll let you go to do the rest of the exercise yourself. So the first thing we want to figure out is what is our expected percentage of hatched versus unhatched eggs. So how do we do that? Well, we take a look at this total number of hatched eggs, 129, and our total number of eggs, 187, and we do 129 hatched divided by 187 is going to give us 0.6898, or in other words, and I think I have to write this, 68.98%. So what we're going to do is now move that over here. So we have 68.98%, and down here we have 31, love this app, 31.02 percentage. So let's move that over there. Okay, so now we're going to use these percentages. So this is, just notice here, the 68.98, all I'm doing is taking and saying 129 of the 187 eggs were hatched, 68.98% of those eggs were hatched, and 31% were unhatched. So now, if I'm guessing in the cold condition, what I want to do is ask this question of, well, I observed 16 eggs were hatched. How many did I expect? Well, I expected 68% of any of my groups to be hatched. That's the null hypothesis. If these groups aren't different at all, I expect 68.98% to be hatched. So I do 0.6898 times the total number of cold eggs, which is 27, gives me 18.62. My expectation is 18.62. So I observed 16, I expected 18.62. So now the next question is, how much did these deviate? So all I'm going to do is take my 16, my observation, minus my expectation, 18.62, and that's going to give me my deviation, which is negative 2.62. Okay, so that's my deviation. For the next step, all I have to do is square that deviation. So negative 2.62 squared gives me a positive 6.86. We're almost there. Now all I have to do is bring this number back down to normality by dividing it by my expectation. Okay, so now I go 6.86, which was my O minus E squared, that's just this number right here, and divide it by my expected value, which was 18.62. And what that's going to give me is 0.37. If I can read my own writing well enough. I think 0.37. Okay, so that's how you do one of these columns. What I'm going to have you do for class is fill out the remainder of these, including some of these percentages on the bottom, and all the O minus E's squared divided by E. And what I want you to find is not only your total chi-square, but also, is it significant? And remember, to do that, you're going to need to Google things. So you need to Google things like chi-square critical value table. You're going to want to pay particular attention to where P is less than 0.05. Okay, so come to class, fill that out, and we're going to work through it, see what everyone got, and then we'll work through another problem in class.